So where we left off, it's not a fun one. So we got 2 cos squared x. What am I? Whoa, what's going on here? Oh, it's doing the glitch. I have to restart. Alright. Two cos squared x minus 1 minus cos x equals 0. Okay, so what was the steps we did yesterday? Oh yeah, you want to use the inverse function. Plug this in on the right side, and then you get one of the angles on the unit circle or something. So I'm guessing 1 is going to be on the right side. Like that, and it's going to be like cos something. What's the double angle formula thing? Or no, this isn't double angle. Double angle would be this. I forget, I don't know if you're allowed to do this. I think I tried this last time, dividing by 2 and then square rooting. I'm just gonna do it though, cause I have no idea what else you're supposed to do. Hold up. That's the tough one. I don't really know what to do here. Maybe like factor out a cos x. Wait, would it be x? Yeah, let's factor out a cos x. This is identity. No. Man, I don't know. What am I supposed to do with this? See if photomath gives me anything. No. Not at all. Not at all, okay. Yeah, see, like this goes nowhere when I do that. Absolutely nowhere. Hmm. Alright, maybe move the one over. Okay. Divide 2. Both sides. Oh. I was hoping I thought the one would be here still, so I could do like this, turn this into negative sine squared x. But if that's not gonna work, then kind of screwed. I don't know. Kind of unfortunate. You know what? We're skipping this one for now. Spent too long on it. Okay, 61. 4 cos squared x minus 3 equals 0. Okay, first thing, I'm gonna move the 3 over. Divide by 4. Okay. That's squared there. Can I just... Alright, then I'll plug it into the inverse. Yeah, we'll try it. Why not? I probably did something completely wrong. I'm plugging it in right now. Square root of 3 divided by 2. Alright. Oh, maybe. Maybe this will work. It's pi over 6 in decimal. Or not pi, square root of 6. Or no, it is pi over 6. Yeah, it actually works. Wow. I could have done it wrong still. I probably did, but this should be. You draw it out. Should be 30 degrees right here. So this would be pi over 6, and the point is square root of 3 over 2 half. And this is cos, which means cos is x. So I want another one of the square root of 3 over 2's in the x, which is down here, it's 330 degrees. I use straight line for this. Whoa. Yeah, that's the same point in the x. And that is 11 pi over 6 in radian. Absolutely sickening, dude. So, let me think about how I did it yesterday. Oh, I'm just gonna look, whatever. Oh, so I just say x has 2 answers. Pi over 6 and 11 pi over 6. I think that's it for these. Oh, plus 2 pi n. Yeah, should be it. Again, I'm probably doing these wrong. And I can't even figure out 60, but I'll just wait for the answer key to come out in like 3 months. Oh, there's 2 more of these? Wait. No, I'm on, okay, 60. I'll do the 62. I hate these ones. So sine squared x plus cos 2x minus cos x. Shrink this. Equals 0. So what do I want to do here? Lots happening. You see? Well, so many things you can do here. Oh, wait a minute. Can I just save this cos x? Does this subtract? No, no way it does. I don't think it does. I could probably photomath that, right? You can tell me if they subtract. I think it would have to be like 2 cos x minus cos x if they were going to subtract. But maybe. Yeah, I could. No, you can't do that. So, that's fun. I'm guessing I have to turn something into a number, right? Because I can't just plug in like a. I have to plug something in. If this was like if this is squared, you might be able to do something. No, actually, it'd have to be positive too. I'm very tempted to skip this one. I'm not gonna lie. Very tempted. Yeah, I can't think of a single thing to do here. So unfortunately, skipping this one for now. Let me get that progress bar up, because I did do one problem. Okay, what's next? That's the end of this horrible problems that I don't know how to do. Okay, let's see. Inverse trigonometric functions. Recall, inverse trig functions can be written in one of ways. Okay, let's typo. So, arc sine x and sine -1x. Yeah, I was doing some of this up there. You good? Inverse trig functions are defined only in the quadrants as indicated below due to their restricted domains. Okay, they're only in. Yeah, I'll just write this down. Bro's dying over there. Cos inverse cos x inverse sine x. Oh, less than 0. Alright, example. Express the value of y in radians. And this is what they give. So what they do, this is an example. They just drew the reference angle triangle down here. And then what they do. This means the reference angle is 30 degrees, or pi over 6. So y equals pi over 6. Couldn't you just plug this into the calculator and like literally what I was doing? I'm gonna try that. You're probably, I have to do work for this, obviously, but this is like actually exactly what I was doing to solve those other ones, which makes me wonder if I was even doing them right. Yeah, and then you'd get pi over 6, or negative pi over 6, negative 30 degrees. That's, yeah. So it's exactly what I was doing before with less steps. Easy. Okay. But they're not numbered, these problems, so no progress. Alright, I'll plug this in first. Square root of 3 over 2. Alright, so I got negative 1.047. What would that be on the unit circle? 2 pi over 3 maybe? No. Oh, pi over 2? No, probably not. No. Is it pi over 3? Oh, it is. 60 degrees. No, it'd probably be easier if I used the calculator I have on my computer. I'm gonna do that next time. So 60 degrees, I don't know, like here or something. I don't really care. $30, $60, $90. What are the things for 30, 60, 90? I think I have to memorize this. Or that's what they say. I don't know if I will. One is across from 30. Two is across from 90. And what is it? The square root of 3. Across from 60. Okay. I'm seeing, what do they want? I'm doing it like backwards. Like I'm getting the answer first and then I'm writing this down. What do they want me to do? They want me to look at their this chart. I can do it like that. It's fine. So next one is y equals, I'm not gonna write arc, cos inverse cos, -1. Okay, so that has to be in quadrant 2. Wait, how do they, what? I'm trying to solve it like the example. How did they know which reference triangle to use? I'm just gonna use a calculator. I think it's whatever. It's not showing up on stream. Hold up. Why is it showing this? There. -1. Okay. I am in radian. Yep. Try 3. 3 pi over 4. Nope. Pi over 6. Nope. Oh, it's pi. Okay. It's this pi. So 180. I mean, it's negative. Yeah, okay. Jeez, dude. My brain's melting. How do you even draw a reference triangle for this? You can't. Like you just, I don't know. The answer is y equals -pi. Yeah. I don't think you can draw a reference triangle. Yeah. Next one, y equals tan inverse tan, -1. Just gonna look at the unit circle. It'd be like pi/2 or something. No? Okay. Or wait, I put in pi. Why'd I put in pi/2? Okay, no, it's pi/3 again? Pi/4? So it's 7 pi/4. Or no, it's just negative pi/4. Or 7 pi/4, but doesn't really matter. And I guess you can, yeah, you can draw down the reference triangle. So I guess I'll do that. So 45, 45, 90. So 1, 1 square root of 2, something. Make sure. Yep. Well, this should be -1. Oh wait, no, I see how they want you to do it without calculator. So you just figure out this is negative. You have -1. You look at that chart. Wait, yeah, you look here. Say, okay, x is less than 1, or x is less than 0. So it has to be down here. Alright. Then you draw this, and you put down. You have the you have that it's -1, so you know you're using the 45, 45, 90. because you can't get -1 on the 30, 60, 90. So then you draw this, and then you know it's 45 degrees, which is -5 or 4. Okay, that's makes sense. Let me try on one where I thought I couldn't draw the reference triangle for. So if it's less than 0, it has to be in the quadrant 2. Has a -1, so it has to be 45, 45, 90. It's negative, or wait, no, it's 10. Negative, positive. I'm gonna type this in again. Oh, it's definitely pi. I don't know how. This doesn't make much sense, actually. Okay, I'm gonna move on. Wait, whoa. Oh no, okay, it's 63. Very good. Find the value without a calculator. Cos 10, inverse 10, 5 over 6. The way they do it, they draw the reference angle. And then they use Pythagorean theorem to find this one, which is square root of 61. And then they find cos. Okay, that's easy. I can do that. So first one is tan arc cos 2/3. Alright. Arc. Whatever. So I'll draw the reference triangle. Which quadrant would I have to be in? Quadrant 1. Okay, This is adjacent, hypotenuse. So 2 squared plus b squared equals 3 squared. 4 plus b squared equals 9. B squared equals square root of 5. Whoops. B equals square root of 5. And yeah, that's it. So we're finding tan, which is square root of 5 over 2. Easy. Actually easy one for once. Next one, seek sine inverse 12 over 13. Okay, that's gonna be quadrant 1. Opposite hypotenuse. Solve for the b. $144. Oh wait, 13 squared. Minus 144. Okay, thank you, calculator. Okay, so b equals 5. And we're trying to find seek. So adjacent hypotenuse 13 over 5. Alright, gotta get a new page. Save this. And we're on 65. I gotta update the counter. Got 2 in. Sine tan 12 over 5. Okay, this is in. This could, wait, can this be in more than 1? No, it's quadrant 1. $12 squared plus 5 squared equals c squared. 44 plus 25 equals c squared. 169 equals c squared. C equals 13. Nice. Same triangle as last time, except for the. Was there a square root? No, there wasn't. So this is sine. Yep. Opposite hypotenuse. 5 over 13. Nice. 66. Sine inverse sine 7 over 8. Okay, 2 sines. All in the first quadrant for some reason. Going easy on us. Opposite hypotenuse. Is it literally just 7 to 8? It would be, right? I'll find the other one. I don't think you have to. 64 plus 49 equals c squared. 113 equals c squared. Error. Make sure I added those right. Whoa. Okay. Well, I mean, yeah, I think the whole point is this is that you don't have to solve for C, which is kind of stupid. And that is 66 solved. Nice. Flying through these after going past the that one set of problems. Took like the whole stream last time to do half of them. Alright, circles and ellipses. Ellipses, whatever. I'm not writing all this down. It's just showing circle formula and ellipse formula. Ellipse along the x-axis and b is the distance from the center to the ellipse along the y-axis. If the larger number is under the y squared term, the ellipse is elongated. Does that mean if the larger number is under the y squared? I don't really know what that means. For our purposes in calculus, you will not need to locate the foci. Really? Nice. I hated doing that. Alright. Beautiful. Okay, so this is a circle centered at the origin, and r squared equals 16, so r equals 4. So easy. It's just 4, 4, or I do actual coordinates, I guess. 0, 4, 4, 0, 0, negative 4, negative 4, 0. Sick. Love this shit. And that's it. Same thing for 68. Different radius. x squared plus y squared equals 5. R equals square root of 5. My calculator disappeared. Nice. Okay. I'm just finding that out for when I have to write it down on paper. I'll just draw like 2 ticks. I'll do that better. So we know it's like a little bit past 2. So I'll draw ticks for this too, why not? Oops. Zero square root of 5. Square root of 5. 0. Negative square root of no. 0. Negative square root of 5. Negative square root of 5. 0. Easy. Easy problems. 65 done. Wait a minute. Did I skip 3? Or no, because I finished 68. Wait, yeah, did I skip 3? Let's... I thought I only skipped 2. I must have... No, yeah, I skipped 2. So I'll update the counter again. Alright, x squared over 1 plus y squared over 9 equals 1. This is looking like a, yeah, an ellipse. Whoa. Okay, so B is distance from the center to the ellipse along the ellipse along the x-axis, and B is the distance from the center to the ellipse along the y-axis. Okay, so it's B if the larger number is under the y squared term. The ellipse is elongated along the y-axis. Okay, so it is larger under the y squared. And you don't need to locate the foci. Didn't give. Yeah, okay. So this is wrong. I'm gonna flip it. One, two, three, four, five, six, seven, eight, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Easy. And we're just gonna say this is 1. Even though it's definitely not. Make sure I did this right. The larger number is under the y squared. It's elongated in the y-axis. If it was the larger is the under the x squared, then it would be normal. Nice. Flying through these. Same thing, pretty much. This time it is larger under the x-axis, so it looks like a normal sideways ellipse. So it's say 4, 8, 12, 16. 4, 8, 12, 16, remember. 4, 4. Nice. Alright. That should be it. Vertical asymptotes next. Three more pages. The last two are kind of stacked. But only 3 more pages. Nice. So determine the vertical asymptotes for the function, set the denominator equal to 0, to find the x value for which the function is undefined. There will be the vertical asymptote. That will be the vertical asymptote. Alright, so 71. If x equals 1 over x squared. You good? A B? What? So you want me to set the whole denominator equal to 0? Oh, wait, no, like... like that or something. So this is the... yeah, this is the vertical asymptote then. Right? Yeah, okay, that's easy. Easy, dude. What? That's all you have to do. It's insane. Actually kind of free. Oh, plus or minus, you cannot forget that, dude. Cannot forget that. But that's it for that. Oh my goodness, man. Flying through these. I had a feeling after I got through what do you even call this? Trig equations? I didn't even like do all of them. I skipped two, but whatever. I'll go back to them at the end of the stream. Probably. Unless I get like hard stuck on something else. I could just say like, no, I could just throw this under the 0, right? Yeah, it's that easy. Because if you set this to 0 up here, everything goes crazy. So it's just x equals 0 again. Oh my goodness, man. Oh my goodness, flying through. Horizontal asymptotes. So wait, let me guess. Set the numerator equal to 0? Or no, it's gonna be like just set the whole thing equal to 0. Just set y equal to 0 maybe. Let me check. Alright. Determine the horizontal asymptotes using the 3 cases. Oh. Degree of the numerator is less than degree of the denominator. The asymptote is y equals 0. The degree of the numerator is the same as the degree of the denominator. The asymptote is the ratio of the lead coefficients. The degree of the numerator is greater than the degree of the denominator. There is no horizontal asymptote. The function increases without bound. The degree of the numerator is exactly 1 more than the degree of the denominator. And there exists a slant asymptote. I remember doing this. It's just determined by long division. Okay, so the degree for this one. What do you get if you set y equal to 0? There's something. What's that called? Yeah, okay, then you find the x-intercept. If you set x equal to 0, you get the y-intercept. Okay. And the bottom, x cubed plus x minus 7. So the degree of the numerator is less than the degree of the denominator. So this is y equals 0. Alright, I'll make sure I'm doing this right real quick. Time to steal some content. You knew it was gonna happen. My man Brian in here.
So,
Not showing up. Okay.
when dealing with a rational function,
I'll mute the music actually. Hold up.
which you could call R of x, and we'd have n of x over d of x, which basically means a rational function is we're going to have a function in the numerator and a different function in the denominator. We can look at those functions as a to the x to the m plus dot, 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 over b to the x to the n plus dot, 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 dot. It really doesn't matter, but remember in Algebra 2 and even Algebra 1 we talked about, or Algebra 2 at least, we talked about taking a polynomial and rewriting it in standard form, meaning that you're going to have your largest degree first and then going down in descending order, right? And then you identify the leading coefficient and the degree. So assuming that I have my two functions, we want to make sure that they're in standard form, where a and b represent the leading coefficient and m and n represent the degree. So when you guys look at this polynomial, you'll see that both of these are written in standard form, right? Where the degrees are both 1, and my leading coefficients are 1 and 7.
So it's 7.
Follow me with that. Okay, so as long as,
Asymptote 7.
As long as my rational function's in that form, there's some tests. Oh, is your horizontal asymptote test. Your horizontal is...
Yeah, okay. We are doing it right. Let's go. So that's another one done. $75. Let's go. This is in standard form, or the top one, the numerator is. Gotta rewrite the bottom. Same. So negative 5/3. $74. No. 76. Let's look at the counter. Oh, numerator's bigger. It's not one bigger though, so no slant. No asymptote. Easy, dude. That's another page done. 2 more pages. 21 problems. Or wait, 31. Yeah, 31 problems. Jesus. Well, 29, because I skipped 2. Laws of exponents. I got this, man. Wait, why am I? What? It goes back to 75? Are you kidding? It just goes back to 75 for no reason. Man. 2a squared power 3. That's just 2a, or 2 cubed a 6 for b. 16. No, wait. Yeah, 16. What's 2 cubed? Is that 8 or 16? Can't think right now. Calculator died. It's 8. Because 2 squared times you just add on another 2 squared, which is 4 again, so. And then 2 to the power of 4 would be 16, I think. Or wait, no. What it? Man, wait, hold up, dude. Hold up. Is it like... It's like this? No, because that would be 12. How do exponents work? What's... Oh, wait. You just 2 times 2. 4 times... Oh, okay. Okay. Okay, dude. So that's 8a power 6b. I wasn't even having trouble with the exponents, it was the, what's it called? Well, it was exponents, but a different way. Different reason. No counter though, because we went back 2 problems. For some reason. 9ab cubed. Over 2. Yeah. That should be it. 77. A to 2B. And then 3A. 3 over A. Okay, you can rewrite this as a... Wait. No, wait. 2a squared 3b. What's that have to do with exponents? Confused. Wait, write each of the following expressions in the form. Oh, okay. Well, I wrote it in that form, I think. Photomath, let's get it. No, yeah, it's simplified. $78. AB minus A. B squared minus B. Well, let's see, you can split these up like this. What's this really do though? Wait, maybe factor something out. Wait, what would be the point of that? Or no, yeah, you could factor out an A at the top. And then a B at the bottom. Oh, wait. I'm seeing something. Yeah. I don't know how much this has to do with the laws of exponentially. Yeah, here we go. We're getting somewhere. Let me get that counter up. So I finished 78, so 76. So 1 over A, 1 over B. So 1 over A at the numerator, square root of A over B. Here, I'm gonna rewrite this. Yeah. And that's status over B. So B. No, actually, I'm not gonna rewrite this yet. Be like that, right? It's A times A power half. See if that can be simplified. So I guess you add 1 plus half, so A to the power 3 over 2. Fair enough. Big one for 80. We got A 2/3, B half, the bottom. That's all squared. B 3 over 2, A half. First thing, let's square all these. So A this be 4 over 9. I'm gonna fit him at this too. I'm not too sure about how to square these. Or wait, no, I think you just multiply the 2 over 1. Yeah, that's how you do it. that, I think. I don't know. Something like that. That's it for the exponent ones. Laws of logarithms. Okay, I forget these. Oh, any more room? Yeah, I forget the laws you gotta use. Okay, so if they have the same base, then you multiply the whatever you call that. So 5 times x x squared minus 1. And those are being added. If they're subtracted, you divide. Yeah, you divide. X minus 1. So yeah, it looked like that. Wait, when can you just cancel out logs? I'm gonna look up a video on logs. Refresh.
FL. We'll go over these notes. Just like the previous notes, you're going to want to have these written down. All right? Now, Dane, just give her a piece of paper, please. There's a couple rules I'd like you guys to remember. A couple truths, I would say that under our understanding of logarithms, everybody, including Shelby, should be able to look up here and agree with me that when we're talking about a logarithm, this logarithm says, actually, I don't know why I gave you guys the answers, but this logarithm says 3 raised to what number is 1? Well, the answer is 0, correct? 3 raised to what number is 3? The answer is 1. This logarithm, 3 raised to what number is 9? We know the answer is 2. Does everybody agree with me, those evaluating those logarithms right there? Right? Yes. Yeah, I mean, 3 to the what power is 9? Well, we know the answer is 2. Right? Agreed. Everybody knows those to be true. Okay. So, there's a couple rules that we were taught in Algebra 2, but we're going to go back over them. The first rule is the product rule. And basically, the product rule states that if you have a logarithm for any base, that means it could even be a natural logarithm, of a value plus the logarithm of the same base of b, well, then that's equal to one single logarithm of that same base of the product of a and b.
Yup.
Okay. Actually, crap. Well, I'm going to write it the other way. It doesn't really matter how you write it. I just want to write it this way I'll show you. Log base b of a times b. We're going to expand it, and I'll show you why. Just because the way that I'm going to teach it. Yeah, because we're going to start today's lesson with expanding, so this would make more sense that way. All right, now I'd like to give you guys an example of why this makes sense. Because a lot of students usually memorize this and they say, okay, yeah, we know that, right? But let's go ahead and start with a problem we know. Log base 3 of 9. We don't need to write the answer. You guys agree with me, we know that answer is 2, right? I could also rewrite that as log base 3 of 3 times 3. Correct? Right? Now, if we follow the rule here, we know the answer is 2. We know the answer there is 2. But if we follow this process, the log of the product of two terms is equal to log base 3 of 3 plus log base 3 of 3. Well, what's log base 3 of 3? We said that answer was 1. So that's 1 plus 1, which equals 2.
Smart.
Oh, I'm not going to erase it.
It all equals 2. That's crazy. Actually insane.
It works, right? So you guys agree. So therefore, I can give you variables and just say, hey, expand this. And you would understand that if they're separated by a product, you can rewrite them as two different logarithms. So let's go to the quotient rule. All right. So now if I go to the quotient rule basically states if you have a logarithm, base b of a over b, we can rewrite that as two logarithms of the same base, or the difference of two logarithms with the same base of a minus b, or log of a minus log of b. Right? Again, let's do an example. So, if I did an example here, I know that log base 3 of 3 is equal to 1, right? Everybody agrees with me. But I could rewrite this in a different way. I could rewrite this as
I don't
log
think
base
that
3
I can make the point.
yeah, 3 base 0, which we knew the other answer. We already knew that was going to be the case. We knew that 3 raised to what number was 1 had to be 0. But I just want you to show by expanding them, we're just writing them in a different format. I'm not changing the answer. I'm just rewriting. And the power rule goes like this. If you have log base b of a raised to the b, then that is equivalent to b times log base, sorry, I don't want to confuse variables. Raised to the c, that's equal to c times log base b of a. Okay? So again, let's try another one. Example, log base 3 of 9. We know that answer's 2, correct? Now, can I rewrite 9 as 3 squared? Of course I can. Right? Now, based on this rule, if I have a term raised to a power, I can put the power in front as a product. Then, what's log base 3 of 3? So do you guys see from the beginning we knew what our answer was? And even by expanding them and evaluating, we figure out our answer. Or an easy problem.
Okay. No, I'm gonna do it one step at a time, actually. So 5x squared minus 5. So divide these. X minus 1. Yeah, I mean, I could just, whatever form works, I guess. I don't know. Can you do anything else with this? Maybe photomath it, see what it gets. Okay, they got something a little different. So they had what I had. Factored out. Okay, I can do that. Yeah, that works. Okay, so 5x plus, oh, okay, I should have seen that. And then you cancel out the x minus 1. Plus 5, and that's it. Alright, makes sense. 82. Let's go. Whoa. Oh, I still have the video up. Oops. Okay, next is 2 log squared. Or, no, I don't even know how to say. I don't know how to say this. That's what I'm writing down. That's supposed to be an L. Why is this easier than the other one? Right? Just 9 divided by 3 should be. Should be it. uh, 3 2 log 3 5. Whatever. Okay. Gotta pull out the rules for this one. Okay, so I can move the 5. Wait, it's 5 at base. Okay. I think I can move the 5 over. No, I can't. No. Can't do that. Can move the 2. I don't know if that'll help. 25. Crap. I can just like get rid of the 3 like that. Or no. I'm gonna photo mount this one, like, it's like weird. Okay, so it ends up being 25. How do you go there? It says use a log a b equals b. What? Huh? So you could just say you could just say 25 or well 5 squared. Well no, because I did that part already, so it's 25. Really? Is that a rule? Okay, man, if it says you can do that. Or wait, you know what? That is on my sheet, I think. Something like that. Alright, cool. So it's 25. Come on, man. $84, let's go. Alright, so first thing, dude. What do I want to do here? I think that's it. No. Photo mount it. Feels wrong, but okay. Well, how'd you get that then? What? That's a rule? Hold on. The answer should just be half. So which rule would that be then? Oh wait, okay, if you think about it. Um 10 to the power of what gets you 10 to the power of half, or something like that. Alright, so if we rewrite this, yeah, so it's half. I mean, it's obvious. Like, okay, if you just think about it, you're trying to find 10 to the power of what equals 10 to the power of half. Well, it's half. It just is. So you could just say that. Easy. I'm not sure like what exact rule that'd be, but I mean I get the concept of it. 85 log base 10. That. Okay. Well, you could rewrite that as like 10 negative x, right? So 10x or 10a equals negative x, 10 to the power of negative x. Negative x is the answer, I guess. Alright. Gotta math it. Yeah, it is negative x. Okay. $86. Let's go. It's a big one. 2 log base 10 square root of x plus log base 10x power of a third. Okay. So I can put the 2 in front towards the back, square it. Then I can multiply these. Oh wait, this cancels out. And this would be like adding the 1 plus a third, so 4/3. Right? Something like that. I'm not gonna be straight at math, I don't feel like checking every single one. It feels right. Solve for x. 5x plus 1 equals 25. Alright, we're already at the end of this. Oh. Okay. Well, x would have to be 4. wants you to. Okay, well, I'll do it with logs, I guess. So move that out front. Or no, you don't even have to. Wait, ln. I think you want to do. I don't know if it matters. Wait, then you can. Wait, no. Don't cancel out the logs yet. There'd be no point then. No. Wait, what do you even. I forget what you even do with these. See what photomath does. The camera will not focus for some reason. It's not solving it using log. Here, I'll write a better one for photomath. Alright, I don't really know. I don't know, man. Write this as a. To ln 5. Maybe then you cancel them out. Wait, no, that wouldn't make sense. Man, I don't know. It's 4. Just gonna look it up on a hopefully a Brian video. No, I'll get some organic chemistry tutor.
This lesson we're going to focus on solving basic logarithmic equations. Let's start with this one. Log base 2 of 16 is equal to x. Go ahead and find the value of x. What we need to do is convert.
Well, it would be 4, but I don't know how to like show that.
It to exponential form. 2 raised to the x is equal to 16. Now you might already see the answer, but I'm gonna go ahead and solve it. Now we know that 2 to the 4th power is 16, so therefore x is equal to 4. You can also do this, log of 16 divided by
Here we
log
go.
of 2. If you type that in, that's equal to 4, which is x, using the change of base form. Try this one.
Wait, can I do that without what I was doing? Let's see.
Log of 16 divided by log of 2.
No, that's not exactly what I was trying to do.
If you type that in, try this one. Log of x, log base x of 81 is equal to 4. What is x? So let's convert it to its exponential form. X to the 4th is 81. So now let's find the value of x. To do that, we need to take the 4th root of both sides.
Alright, I mean, I'm just x equals 4. I mean, how else can I show it? Yeah, wait, I know. Wait. Alright, equals 1. Yeah, why was I saying 4 the whole time? Oh, man. It's embarrassing. Alright. Yeah. So that's 87. I remember there was a way I did it before where it was like you put the log in and then for like no reason. Just to take it out again, but I don't really have to do that. As far as I know. I gotta save this. Third equals 3. 2x plus 2. That got cut off. Nice. Alright, well, let's see. If I do the thing. This over. I'm a fit math. I don't know. Oh, wait. Oh, man. It's so easy. Or at least the first step that I saw was. What I already said. Okay. You just rewrite that as 3 to the power negative 1. Yeah, it was that easy. Alright. 89. Okay, well. This is saying that 3 x to the power of 3, or no, 2 to the power of 3 equals x squared, I think. I think. I'm thinking. And we know it can't be negative. Because you're squaring it, I think. Maybe, I don't know. Or no, maybe, I don't know. I don't know, man. Okay, it can be positive or negative. I'll rewrite that too. $90. Alright. All these can go away. It's 5 to the power of 4. 625. Negative 609. We do the cake method. Okay, that doesn't work again. Nope. Yeah, it's not even. 6, 7. 7 maybe. So we have 3 divided by 7. Yep, 29. Is that prime? Yep, okay. So, doesn't simplify. It's like that. I'll check this one. No. No, okay, what do they do? Okay, they go crazy. What is this? Oh, it's a -4. Okay. So what they do? They keep the logs for a while too. Right, first move this out. Move that one out. So this would be plus log base 3 5 -4. Okay. Changes things. It's 5 to the power -4. -625. Wait a minute. Oh, wait. No. It's 1/625. Forgot how negatives work. Alright. And then multiply them together. (16/625). Does that simplify? No. Okay. That should be the... Wait, is that the answer? I guess so. Yeah? Okay, so 4 plus or minus 4 over. What did we get 625 from? 5. Wait. It's a square root, that's different. $25. Okay. So yeah, that should be it. Nice. That's 90 done. Last page. And like I said, I might go back, retry the 2 problems I skipped. But maybe not, I don't know. Alright. Factor out an x first. X 4. And then just get this. No, I guess not. It's 4s. It's gonna be. Plus 4x minus 4x, negative 16. Okay. Do I rewrite this as like? Wait, no. Factor completely. That? No. Wait. Hold on. Better math. I'm not very good with this. No, that's it. But I had a right here. That should be it. Alright, I'll be right back. I'm gonna watch her keep organic chemistry tutor talking about solving log equations.
So the fourth root of 81 is equal to 3, because 3 to the fourth is 81. Now what about this one? Log base 5 of x is equal to 3. Convert it to its exponential form. 5 to the third is equal to x. That's 5 times 5 times 5. 5 times 5 is 25, and 5 quarters is $1.25, so 25 times 5 is 125. Let's try some more examples. Log base 32 of x, let's say it's equal to 4 over 5. Go ahead and try this one. So 32 raised to the 4 over 5 is equal to x. And what is that equal to? What is 32 raised to the 4 over 5? How can we simplify this exponential fraction? So first, you want to find the fifth root of 32 and then raise it to the fourth power. So what number multiplied it by itself 5 times is 32? 2 to the fifth power is 32. So therefore, 32 to the 1/5 is 2. So now we got to find out what 2 to the 4th is equal to. 2 to the 4th is 16, and so x is 16. Here's the next one. Log base 3 of 5x plus 1 is equal to 4. Find the value of x. So let's convert it to its exponential form. 3 to the 4th is equal to what's inside. And 3 to the 4th is 81. Let's subtract both sides by 1. 81 minus 1 is 80. And if we divide by 5, 80 divided by 5 is 16. So that's the value of x. If log x is equal to 24, what is the value of x? Now we don't have a base. If there are no bases written, it's assumed to be base 10. So this is going to be 10 raised to the 24th, which is a very, very big number. So I'm going to leave it as 10 to the 24th. Now what about this one? ln x is equal to 7. What is the value of x? Natural logs have the base e, so e to the 7th is equal to x. And that is the answer. Now if you want the decimal value, x is approximately 1096.63. Try this one. Log base 7 x squared plus 3x plus 9 is equal to 2. So let's convert it to its exponential form. 7 raised to the second power is equal to what's inside. That is, it's equal to x squared plus 3x plus 9. 7 squared is 49. And let's subtract both sides by 9. So 40 is equal to x squared plus 3x. Let's move the 40 to the right side. So x squared plus 3x minus 40 is equal to 0. Now what two numbers multiply to negative 40 but add to 3? This is going to be 8 and negative 5. So this can be factored to x plus 8 times x minus 5. So x is equal to negative 8.
Alright, it's 92. Let's go. So we can't factor out an x. Factor out a 2. That's about it. No, we can't even do that. Okay. Nice. This is how it's gonna be. Isn't set equal to 0, so does that mean I can't use completing the square? Okay, where do you even start with this one? Well, this one is wild, man. I'm a photo math it. Look at the first step, just the first one. Okay, well, it just goes straight, gives me the answer. Backdraw x minus 2? Wait, what? Huh? Okay, so this is what Photomath is doing. They're doing some weird stuff. So they're taking out an x minus 2. So just looking at this. What? What the? Well, I gotta look at this screen. Because what are they actually doing? Oh, okay. Okay. That's creative. Very creative. But what do they do with that? Oh, then they okay. I would never figure this out. Straight up. Wait, what? What? Okay, okay. Alright. Yeah, what is... That's, yeah. So that's one of them. And then you're left with 4x cubed minus... Wait, no, squared. I don't know why I got that cubed back. Just a lot easier. Wait a minute, can you go even further? No, okay. Yeah, I'm cheating the whole way. It's whatever. 2x minus 5, 2x plus 5, okay. And I'll do the, I'll make sure, even though Photomath told me. Minus 25. Yeah, okay. Yeah, very creative. It's a tough one. I totally figured it out. Let's go. Eight x cubed plus 27. Unless you get anything you can factor, like besides just doing it, I guess. I think you just gotta do it. 2x 3 2x minus 3 2x minus 3, maybe. Yeah. Okay, I'll just do these two first. Wait, what is this? Wait, what? No. No, this is wrong. Alright, Photomath, what are you doing? So first thing they do, write the number in exponential form. Okay. That. And then it does this. Okay. It was? What? Oh, they go crazy. What is this? Let's me to use this. Like what? Oh wait, I know on the right side I rewrite it. What is this formula like? What, I've never seen this. I feel like they're just making this up, honestly. Like, what even is this? That's it? Yeah, like what? That is the weirdest way to get that, I feel like. I'm gonna look up what this is. Okay, it won't let me find out. It won't let me copy paste. So should be at 91 out of 105, I think. Uh, I think it's just this. Yeah, that's it. I'll make sure this is the form they want. I don't know why that was the last one. Oh, okay, the way they write it. Okay, I'm in, sure. I'm just gonna keep my... yeah, I'm just gonna keep this, whatever. '95. Solve the following equations for the indicted variables. For A, okay. We'll move these over first. And then... Alright. I think that's it. Next one. for A again. First, I guess, factor out the A from here. No, you can't. Okay. Okay, move the 2BC onto the other side. Then factor out the A. Divide, that should be it. I think. Okay, this next one's saying to use a quadratic formula. It said hint. That's a pretty big hint. For positive R. Okay. Quadratic formula. Can I copy paste this? Or copy image, I guess. What, this is what I copied over? Are you kidding? What's it copying like that? Fine, I'll write it down, whatever. Has to be in standard form first, actually. That. Factor out the 2 pi r or something. Wait, then the A would, okay, wait, hold on. Yeah, I still don't see it. Okay. Still don't understand. Photomath, please help me out, man. I think I'm using Photomath a little too much. Whatever. Photomath, or yeah, Photomath solving for H. Here, solve for R. Okay, what form did they put it in before? They put in the quadratic formula. Two pi r squared plus 2 pi hr. HR. Whoa. Minus a equals 0. So go to this. I mean, I was getting there. I think. Something like that. It's like almost in standard form, I feel like. Alright. So, a equals 2 pi. Okay, okay, and then b equals 2 pi h, c equals negative a, or something. Yeah. Alright, now we can plug this in. Wait, what? Yeah, okay, I did that right. Minus 8 pi minus 8 pi a plus 8 pi a. Okay. What form do they have this in? Simplify. Oh, simplify the radical. Okay. Wait, but how's this 2? Why'd I make that 2? Should be 4. To get it. The rest was right. No, it's 2. Okay, oh wait, the 2 goes away here. The 2 over here. Yeah, and then it just becomes... Wait, why do I have this x? Because we're solving for r. Yeah. I don't want to write this 2 times again. So that's the answer. Okay. Which one am I on? 98. A equals P plus XRP 4P. You got it, man. So factor out a P. I feel like I'm doing something wrong. Because of all I had to do for the last one. But I'll wait for the answer key. Coming out in 3 months. Two x minus 2yd equals y plus xd 4d. 4d, okay. So I'm going to put all the d's on one side. And then move the y on this side over. And then I'm going to factor out the d. Wait. 2y plus x divide. This feels too easy. But we'll go with it. 98, wait, no. 100. This one looks annoying. For x. Okay. Factor out an x right away then. Wait a minute. Wait 1 minute, dude. Would this not just be... Wait, what? Does this equal 0? It does, so it's just 0. That's it. Oh, okay. Yeah, fair enough. Oh yeah, I mean, it has to be, because if you plug... If you look at this, if this equals 0, then it yeah, okay. The numerator has to be 0. So, or wait. But if you plug in 0 here, then you get half equals 0. It'd have to be 1. But then you... What? Something's not right. How does that happen, man? You know, you can't factor out an x at the beginning. That's why. So I'm going to move the other one over. Oh wait, that doesn't help. That's That's not very helpful. Oh, what else can I do? 2x 4 pi multiply by 4 pi? No, because this is a weird one. I'll just move the 1 minus x over 2 over. Seems really off. Like, what is this? Thought it was so easy at the beginning. I shouldn't have tried to put it in. I should have just been like, yeah, that's it. I gotta photomath it. Okay, so first thing to do, multiply both sides by 4 pi. Okay. I'll stop looking. I'll just try that, and then, yeah. Then move the pi over. Factor out an x. Yeah, and then, okay. Very smart of Photomath to do that. I mean, me. Very smart of me. Nice. See, I wouldn't have multiplied by 4 pi because I would have thought that would never have worked. That just seems like crazy. But. So which one is that? 100? Okay. solve for x. Okay. I kind of want to use completing the square. Yeah, why not? I always forget it. Let's see if I can remember it this time. Okay. X plus 6 squared. Try it. Or wait, 4x, 2x plus 6? What is it? No, you, factor out of 4, I think? Yeah, then divide by 4. Okay, I forgot for a second, but I think I'm starting to remember it. X plus 3 squared. No. Man, what did I do? Well, I was so close, I think. You can't do this. Man, I was so close remembering. How do you do this? Let's get a Brian or whatever.
Maybe see after that if I can go put it in for you, but maybe not. All right. So, ladies and gentlemen, I went over. So really what I'm doing is I'm squaring inside the parentheses. And my parentheses are being multiplied by 2. So really, since I added 49 over 16 multiplied by 2, think of it like this. X plus 7/4 times x plus 7/4. If you wanted to kind of work on factoring it, does that work? Does x times x give you x squared? Yeah, 98, and then divide by 64, both sides. I have to undo my multiplication. So I divide by 2 on both sides.
So it moves the 4 over. Okay. Then what is this? What's... Okay, no, okay, I understand. If you factor out the 2, you could have the 2 on this side, I think. Oh no. Okay, wait. Where did that 7/4 come from?
Comes the most important point that students often miss, is they forget to multiply by what your 49/16 is being multiplied on the left side. See here, I'm adding 49/16, right? But I added it inside the parentheses. And my parentheses are being multiplied by a 2. So really, since I added 49/16 multiplied by 2. So on the right side, I add 49/16 multiplied by 2. Okay? Remember, whatever you do on the left side, you have to do on the right side equally. Okay, so now I can rewrite this as a perfect square. Now, how do you write this as a perfect square? Remember, the easiest kind of trick I always like to do is just take whatever my b divided by 2 is, and that's going to be your perfect square. You can think of it like this: x plus 7/4 times x plus 7/4. If you wanted to kind of work on factoring it, does that work? Does x times x give you x squared? Yes.
Oh, okay. Let me try that. That'll tell me if I'm wrong or not, I guess. Okay, so plus 9. Wait, hold on. Plus 6. Hope that doesn't work. Wait a minute, why is that at 9? Wait, no, that's right. Okay, so subtract 3 over. Okay. Plus 6 squared on both sides. 33 on this side, 36 on this side. Alright, so photo math, let's go, man. Let's actually go. Focus camera. Okay, so they're using quadratic connect. They're completing the square. Okay, they moved over to 3. I got that part right. Thank God. Divide both sides by 4 right away. Really? So they wasted no time doing that. Okay, I'll do that then. So x squared plus 3x equals negative 3/4. Okay. Now do completing the square? Wait, 3/2? So it should be something like this. Let me check. Yeah. Okay, it goes off the rails again. What did they do? They rewrote it? Or no? Wait. Oh, okay, I see everything they did. Okay, I don't even need to look at it anymore. Okay, so x squared plus 9/4 equals 3/2. So then subtract it over. Minus. Wait a minute. Wait. Hold up. This doesn't seem right. What did I do wrong? So is it squaring before it moved? Wait, hold on. So x plus 3/2 equals square root of 3 square root of 2 or something? Really? No. No. How'd they get square root of 6? It's very, preposterous of them. Well, because the way I would do it, besides subtract 9/4, on both sides. 6 over 4 minus 9 over 4 minus 3 over 4 plus or minus 3 over 4 over 2. But they have a square root of 6 plus 3 plus or minus 3 over 2 once. I'll just go with what I have because I don't like know. So I'll look at the answer key whenever it comes up. I'm going to 2x plus 1 is 5 over x plus 2. We're solving for x, so it's the first thing I want to do, I guess. Multiply x plus 2 both sides. Two x squared plus 4x plus x plus 2 equals 5. Okay. That's another one of these. Okay. Might as well subtract the 5 over because I already know what I have to do. Plus 5x, 2x squared. Okay. Alright, completing the square again, I guess. I guess I should have just kept the 5 over because I have to move over anyway. Remember? Five over 2. So what is this, 37 over 4 on the right side? Man, what? You know, I hate to do it, but I've been doing it all night, so we're going back to photomath. I swear I'm trying. Wait a minute, you don't even have to... Was I doing way more than I had to? You can just factor this. Oh. Oh, okay. So wait, hold on, I still kind of don't get it. So first thing to do. Whoa, no, not that. They do the same thing I did with the moving over the x+2. Yeah. Okay, but instead of doing all that, and they don't foil that? No, they do. Okay. So kind of the same thing so far. And then it's factor from here, I guess. Wait, 6? Wait, what? You're right. 5x as a difference. Are you kidding me? There's no shot, no human would be expected to do that, man. Like, what? They just pulled that out of nowhere. I know it's still 5x, but like, what? Then they factor out 2x. Like, nah. No shot they did that. Factor out x+3. Are you seriously? Wait. What is even going on? Factor out the negative over here. Okay. What in the world? They're factoring everything. Okay, why is this a... It should just be x+3, not no x should be here. Yeah, no x. And they factor out. Then they factor out the x+3. So it would just be 2x minus 1. Yeah, what? That's insane. What? No way I'd ever get that. When the product of factors equals 0, at least one factor is 0. Okay. So x+3 equals 0, 2x equals minus 1 equals 0. X equals -3. 2x equals 1. Wait. Oh, and x cannot be 2. Because if you look at the beginning, this would make it a undefined. Okay, it's still like, what? -3, it can't be 2, half. Oh, and that's it, no 0. That is crazy. What? Would never figure that out. No 3. X plus 1 over x minus x over x plus 1 equals 0. Okay, let's go. Wait a minute. Let me split this apart. This is weird. Okay. So 1 minus x for x plus 1 equals negative x. And then negative x for x plus 1 equals negative x minus 1. Factor out a negative. Multiply by x plus 1, both sides, maybe. Alright, I'll just, x squared plus x plus 1, x squared plus 2x plus 1 plus x squared plus 2x plus 3x, no wait, plus x plus 1 equals 0. Maybe? Squared plus, that'd be 2x. Completing the square. Okay, plus half equals negative half. Should be x plus half. That does sound right, actually. I think about it. X plus half squared. Squared plus half x plus half x. Can't think. Plus fourth. Wait, what? No. So that's not right. Man, what? I didn't square, that's why. No, it was just stupid. That's right, I just have to square it. Wait, which means I have to add fourth. Which means this is negative 4/4. Negative 3/4. Plus or minus. This equals 1/4 plus or minus square root of 3/2 or something like that. I don't know. I'm not gonna check it. Source. Made it up. Go. Polynomial division. Is that like that long division thing? I'll look it up real quick. Last two problems, so. Besides the one I skipped. Wait, so. No, 101. Okay.
You can make videos, yeah, it's a camera. It's awesome.
Yeah, it is the long division thing.
Alright, what we're going to do is we're going to do the long, grueling way how to divide polynomials. But it's very important for you to understand how to divide polynomials in this manner, because if you can divide polynomials in this manner, you can divide any polynomial, and polynomial by another polynomial. So it's very helpful. I know we're going to learn synthetic division in a second, but I want to show you guys at least the long way version first, because this can always be your default method. So when solving this problem, what I'm going to do is first thing I'm going to set up like a long division problem. X minus 3. Let's go a little bit farther down.
I remember
X minus
these
3
weren't too hard the last time I did
divides
them.
into x
I don't know if I was
plus 4x
thinking of something else or if it's
minus 3x minus 12.
these are gonna be harder.
So I want to say,
Like I was doing easy ones
how
before.
many times is x minus 3, can that be divided into this long polynomial to the third degree? So when we're doing this, we have a binomial, right? Which one do we divide into? When you had a number, it was easy. You always just took that number and you divided everything into it, right? Here, I have a binomial. I have an x minus a negative 3. Well, if you guys look at this, see all these x's? I can't divide my 3 into my x. However, I can divide my x into these x's. So I'm going to start with my first number. And that's the number I'm always going to work with as far as dividing. So if I can't divide this x into a number, it can't be divided. All right?
So I look at this first, I say x, can that divide into x cubed? And yes, it can. It can go in there x squared times. And what do I mean it goes in there x squared times? Well, you can check your work. X squared times x gives you x cubed.
True.
Okay, so therefore I know is yes, x cubed goes in there x squared times, because those two multiplied give me x cubed. Now, this is where we get our -3 back into the game. This is how we use this -3. When I multiply back, I gotta make sure I multiply the x squared also times my -3. So x squared times -3 is a -3x squared. You guys wanna know where everybody makes the mistake? Well, right here. When you're done with that, we need to subtract the two lines, right? So everybody writes a subtraction sign. And they do x cubed minus x cubed is 0x cubed, which is 0. Then they do 4x squared minus 3x is x squared. Okay? It is plus, because what you need to notice is I'm subtracting this whole line. So if you want to, you could think of this as like parentheses. I'm subtracting everything that's on this line. So therefore, that's a negative, and that now becomes a positive. So it's really, your answer is going to be 7x squared. No? That makes sense?
No,
Okay.
that makes sense at all.
I mean, look at it this way.
Wait till the answer is 7x squared below.
Yes.
Alright.
All right, you're subtracting the whole line, right? That's a -3x, right? X squared times -3x. 4x squared minus a -3x squared. Double negative makes it a what?
Positive.
Positive, so that's why I get 7x squared. Just think of it this way. It's 4 minus a -3x
Oh,
squared.
you confused me when you put the parentheses in there.
Right, well,
Just the,
Yeah.
okay. It's
Okay,
just
so
normal.
it's just 4 minus -3x. But so many students don't want to go back to this negative, and they always forget it. So they just do the whatever sign's in front of there. And so now I say, because x go into 7x squared, it goes in there 7x times. 7x times x is 7x squared. 7x times -3 is a -21. X. Now, I have nothing to subtract my -21 from, right? So that's why I can bring down a -3x. Now
Wait, hold on. This gets kind of crazy.
Sign
Hold on.
negative
Oh,
3x
I
squared. Always forget. And so now
So I know this comes
I say,
7x.
because x go into 7x squared, it goes in there 7x times.
Oh, okay.
X times x is 7x squared.
Minus 21.
7x times -3 is a -21.
Oh, wait. Wait, what?
X.
Oh, okay.
Now, I have nothing to subtract my -21 from, right? So that's why I can bring down a -3x, and I'll bring down the -12, just so the -12 is not alone. And this cancels out to 0.
And you gotta
Again,
do this.
we're
Foil the
subtracting
negative or
whole
whatever.
line, right? So -7x squared minus 7x squared is 0. -3x minus a -2x is going to become a positive 18x. X goes into 18x 18 times. 18 times x is 18x. 18 times -3 is a -54. Bring down my -12. This gives me 40. -12 minus a -54 gives me 40. Now, do you guys remember in, what was it, like 3rd or 4th grade, you guys did like R, where there's like 5, and then like, and 6 R? Yeah, so it's your remainder. So when I have a number,
Oh, I wasn't paying attention. So, drags this down, subtracts it again. That's down. I'm guessing he does the, yeah, 18x minus 54, subtract them. Okay.
number at the end, binomial does not evenly divide.
I'm gonna keep
into
this up so I know. Alright, focus up. 2 more. Let's go. 104 x power 5 minus 4x power 4 x3 7x x1 divided by x plus 2. So I'll rewrite this. X plus 2 x power 5 minus 4x power 4 plus x power 3 minus 7x. Is that plus 1? I can't even read my own writing. Plus 1. Okay. So first thing, how many times is x going to x? Yeah, how many times is x going to x power 5, x power 4? I think. Yup. Then that's x power 5 plus 2x power 4 minus so minus x power 5 minus 2x. So it should become negative 6x power 4. Okay. How many times does x go into that? Minus 6x power 3 minus 6x power 4. That's what it should be, right? Yep. Subtract that, so plus, and then plus 12. I'm doing like a lot of steps in my head, I might mess this up. Plus 12x cubed, so drag this down. So 13x cubed. Okay, how many times does x go into that? Plus 13x squared. Yep. Okay, so negative 13x squared plus, no, minus 26x squared. Drag this down. Oh wait, you got a what is it? 0x squared or something? You gotta put in like a placeholder. I think that's how you do it. Man, this is annoying. Okay. Okay, should be right. So negative 26x squared. How many times does x go into that? Minus 26x. Minus 26x squared. Well, plus. Minus, what's 26 times 2? 52. Minus 52x. Could be plus 52x. So many places I can mess up here. Minus 7x. Wait, this is squared, right? Yeah. 52 minus 7. These are kind of fun, but easy to mess up, I feel like. 45x. What now? Just plus 45. So minus 45. X plus 45 times 2. 90. Never mind, I gotta move this over a little bit. There's not much left, but. So it'd be minus 90. Plus 1. Negative 89 is all that's left. What do you do for remainders? I forget. Look it up.
Is it 42, right? That was probably like 3 or 4 times overhead. Thank you. So therefore, my answer, this is how I write it with the remainder. My answer is x squared plus 7x. We don't do like r. You just do your remainder 42 divided by your divisor, which is x minus 3.
Really? That's it? Well, I mean, that's how he does it, so it's probably right. Minus 89 divided by x plus 2. Yeah, I kind of like this. It's 105 as long. Yeah, okay. This one has a x cubed plus 1 is what we're dividing by. That's weird. Well, I guess we'll see what that does to it. I'm not gonna write out like the whole. I'm just gonna start. Write smaller. Oh, I'll put that counter up. Of course. Okay, that's it. So, first thing, how many times does it go into x power 5? X squared. So, minus, and then minus x squared. Okay, that is weird. Like it can't do that. How does that even work? Photo math, baby. Let's go. Photo math doesn't really help. Photo math plus, are you kidding me? I can find a better video. Or this is a good video, but I can find a video that'll have a harder. There, okay.
Raise your hand if you're having trouble. So,
Yeah, 2 polynomials.
this is a division problem, correct? We have our divisor and we have our dividends. Basically, actually, what the question is asking is this a factor, correct? Or actually, no, but that's what the question is asking. So real quick, I just want to go through this. Remember you guys did factor trees? Right, like 4 times 3 and 2 times 2. Right, you guys remember like a factor tree? Now, what's important about all those factors? Why do we call them factors? Well, there's some kind of characteristic that they all have in common. Right, they all divide into the number 12, right? All of these different factors all divide into 12, correct? They all divide into it evenly, yes? Evenly. So what the question is asking is not actually just do division, but what actually this question is asking from the textbook is x squared plus 1 a factor of this? Now, if you know that that's a factor, then that means that it evenly divides, meaning we're going to have a remainder of 0. So if we have a remainder of 0, it is a factor. Yes? And what else do you guys remember about factors? Factors we can always write as, what can we find using the factors? No. Dun, dun, dun. Okay, real quick, before I even get into this.
I have no idea.
X plus 1 times x minus 3 times x plus 4 equals 0. Do you guys agree with me? Those are all factors of the polynomial? Yes? What happens when we have our factors equal to 0? We apply the 0 product property, right? So x equals -1, x equals 3, x equals -4. So if those are all factors, those are all the zeros, right? Or the solutions, or the real x-intercepts, and so forth. So if this is a factor, what can I determine from that? I know if this is a factor, then I can set it equal to 0 to find the zeros, right?
Yeah, hold on. Let me check. Is that it? Wait.
Getting a little ahead of myself, but I just want you guys to understand that if this is a factor, you can find the zeros from that, okay? But before we get to that, we want to understand, is this first a factor? So we're going to set it up using long division.
Okay, wait, I'm getting ahead of myself too. No. Get rid of this. Go.
Squared plus 1 equals 3x to the 4th minus 4x cubed minus 12x squared. Is there just an x, a linear x? Is there just a linear x, Anthony? No, thank you. So since there is not a linear x, I am going to substitute in a 0x. So if you have any missing terms, I think it'd be easier for you guys.
Yeah, that's what I did last time. Is there a missing term here? No.
To substitute them with a 0x rather than cleaning out your nails, okay? So if you have 0 times x, because what's 0 times x? 0, right? So in reality, it's not affecting or not changing the problem. Does everybody agree with me? Okay, so, but I want to represent this, and I'll show you why. So when you're dividing this into all of this, we're going to use the same process we did with long division of numbers. But what you're going to do is you're only going to use your x squared as your divisor. That's it. You're not going to use the rest of the polynomial. 4. So you want to have 3x to the squared times. No? Or divide 3 times x to the 4 minus 2. 3x squared. So then what you're going to do is you're going to take your quotient, and remember how we multiply 3 is plus like squared 3x to the 4 for this x cubed.
Wait.
So what I'm going to do is I'm going to use 0 as a place value.
Smart. Okay. Let me see how far I can get with that. Let's see. So negative x squared minus 0 x4 plus 0 x power 3. Okay. Oh wait, I gotta This is a positive x squared, so it's a negative. This is a positive, so, I mean, it doesn't matter at all, but not for the zeros. So I'm left with negative x power 4 plus x power 3 plus x squared minus x plus 4. I guess I don't need to bring that whole thing down. Not yet. Let's bring down negative x power 4. Okay, so to get that, I want to do negative x power 3. Wait, no. Negative x. Yeah, that's all I gotta do. Then plus x power 4. And then negative x. Which goes all the way over here, which would be actually a positive x. This gets kind of weird. So this is an x squared. Okay, this is a x cubed. This is positive. That's positive. Wait, no, this is 0. Yeah, we don't use that anymore. 4. I'll drag down. Okay, I just gotta look at the bottom here. This is like really easy to mess up. This is also 0. I'm not gonna write that down though. So okay, I'm just gonna drag down everything actually. Four x squared x cubed. I think that's all I'm left with. So x cubed is just 1. Multiplied by 1. Or negative 1. Negative x cubed minus 1. Which would actually be plus 1. X squared plus 5. And it doesn't go into x squared, so. Okay, that's the remainder. Okay. I think I'm right. So x squared minus x minus 1 plus x squared plus 5 over x cubed plus 1. Should be it. Alright, and that's all 105 besides those 2 I skipped. So I'll go back and just glance at them. Alright, I'll try both of them one more time. Okay, it was on the first one that I skipped them, right? Yeah. Now that I'm looking at them again, yeah, I can say that I still have no idea. I'm gonna ask my teacher. So yeah, for the purposes of the stream though, that's 105 out of 105. So we're finished. Next stream will be Paul's online math notes. Very exciting. Yes, that's it.